Good morning. My name is James Little, and my company is Mass Spec Interpretation Services. Today I will be presenting a talk on the novel Wiley adaptive MS search for the identification of unknowns. It's part of the Wiley KnowItAll software suite that is an integrated vendor-neutral data processing solution for spectral analyses that includes both mass spec, infrared, NMR, and other spectral techniques. The KnowItAll adaptive search is a patented approach and is based on initial research found in a NIST hybrid search reference, which is noted below. The adaptive search finds similar compounds where a molecular fragment is absent or present in the reference spectrum compared to the unknown. The presence or absence is designated by its delta mass, which is the difference of the nominal molecular weight of the known versus the reference. Peaks in the unknown spectrum are compared to the reference spectrum shifted by this delta mass, and the blended hit quality index value reflects both the shifted and the unshifted peaks. The results are that the adaptive search routinely yields useful results not found with the more traditional identity or similarity search if the component is not present in the reference libraries. Thus, it greatly extends the effectiveness of all reference and even user libraries. In my personal experience, I've done over 40,000 Wiley adaptive or NIST hybrid searches, and I've been routinely amazed at the results obtained. Let's go to the KnowItAll software, where I first opened up a spectrum by the top hand corner by opening a spectrum or structure option, which you can see the spectrum below, and then you need to set up the settings for the search. We're first going to do the standard similarity search just to compare what types of results you would get with the adaptive versus it. So let's look at the settings. For the user select for the databases, I've picked all of the GCMS databases shown below. Before I do the search, I want to go back and make sure I've got all the other parameters set right. So you have to click on Spectrum MSGC to get back to the top level. I'm doing a single component search, the dot product, which is the standard similarity search in the Wiley software. And I'm going to look at the advanced settings. Everything looks pretty good here. There's no changes that need to be made. So now we can do the search by clicking the search button on the bottom right hand corner. It quickly does a search of over 1.2 million compounds, and you'll see that if you look at the bottom for the hit quality index, there's very little useful information. Usually if you get down in the 50%, there's not going to be the exact or a highly related structure in the library. So the other thing that I wanted to note here is if your database is set up so it doesn't show implicit hydrogens, it'd be a good thing to put implicit hydrogens, because if you don't, you can see if it's not, the hydrogens on nitrogen will not be displayed. So always go up to your view and show implicit hydrogens. Now let's go back and try an adaptive search and see what results are obtained. To get back to the search it window, you can go up to the top left hand corner and use the back arrow to go to the previous application. We're back at the initial setup option for the search. And what we need to do is change to the adaptive search. We'll use the same libraries that we used before. The one thing that makes the adaptive search work the best is to put in the molecular weight of the compound, which is the molecular mass to charge field shown here. If you look at the mass spectrum, it appears to me that it has a molecular weight of 286 and contains a bromine. If you didn't know, if you're not very experienced with mass spectrometry, you might want to use their option where it determines the molecular weight for you. So if you go to this icon up here at the top, where it looks like a little light bulb, and push the button, it'll go through several different permutations to determine what the molecular weight might be. It usually takes around 20 to 25 seconds to do this, depending on the compound. If you don't do that, you can just send it to the search with nothing in that field, and it'll try to determine the molecular weight on the fly but it will not do as good a job as if you've used the light bulb function to determine it, as shown in this example now. So it's about to finish it up. So you can see it does take a little while. The other thing is you could just enter in the molecular weight yourself, so I could have just typed in 286 in the molecular mass to charge myself and done the search. So you really got 3 different options that you can do. It says that the estimated mass of 286 was found with more than 87.5 confidence, and you say, okay. You notice it actually inserted it into the field above, where I could have just typed it in. And now, since there's no other parameters to be changed, we can go to the bottom and do a search using the adaptive search this time. I don't know if you noticed, but the adaptive search takes more time than the standard similarity search. And that's because it does a lot more permutations in determining the results. If we go down and look by clicking on the bottom box down here to highlight it, we found that now the hit quality index has gone up to 95.45, so a big increase over that noted in the previous search approach. So I also reviewed some other results, but the actual, I'm now using the arrows on my keyboard to step up and down to look at some of the other ones. You can quickly review them that way, but by far the top one is the one that I'm most interested in. Well, what type of information is it telling you? Well, it's telling you, you can see the structure up the right-hand corner, and now we go back to the bottom display. It tells you that the delta mass between that structure at the top-hand right and yours is 18. The other thing is it shows you is how it calculated this. So if you click on the eye, it'll open another window. This is very informative on how the adaptive search works. We have our unknown on the top, the query, and it's been shifted, as it says here, by 18 in the molecular weight. And here's the bottom uncorrected reference spectrum that it used to compare to get that 95+% hit quality index. You can see anywhere that it has these dashed arrows, it moved that part of the spectrum up to get this corrected reference spectrum. And any place that it did not, like at this mass to charge 99, it did not move that. So it's really a blended spectrum that's a mixture of the regular fragment spectrum that one would note, plus the masses that the algorithm has decided to shift. You can see it does an amazing job of doing this, but really this is how it works. So it corrects all of the reference spectra that it searches versus this to calculate this blended hit quality index, which is, in my opinion, is quite an amazing process. So the last thing in the column noted at the bottom is the replacement. And it didn't quite get the whole statement in that size window, so I'm grabbing it on the side over here, grabbing the line and opening up. And it says, in the unknown, fluorine replaces hydrogen in the reference. It also talks about sulfur, but in this case it didn't make much sense for this statement in regard to this search. So we're going with the idea that probably fluorine has been the change in the spectrum. So in the adaptive search, you don't just get a structure, you have to take the information and propose a structure. So here's the structure of the unknown proposed by the user from the adaptive search results. You can see we started out, this is the result over here for the adaptive search, and it says that we had a delta 18, and we're proposing that fluorine has replaced hydrogen on the structure. And I started with the idea that it's probably on the aromatic ring. It could be on the other ring, but you don't really know which isomer that it is of this. You'll note at the bottom of the screen that I have 2 tabs here. I have my adaptive search technique that I did first, secondly here, and then over to the left I have my original search that I did by the standard search. We can go back and forth between these results, so I'm just going to click on the other one because after I get a proposed structure, I often go back to the regular search to see if it can give me some indication about fragments. And so I'll select the first hit down at the below, which was 53%. What I'm going to do is step through these hits using the arrows on my keyboard, the up and down arrows, and then look at the display in the upper right hand corner to see what type structures it proposes. First one doesn't look very interesting compared to what I propose. But look at the next one. It shows the bromine and the fluorine on the ring. So you can see that it's picking up on this 187 ion. Here is the adaptive search result for the reference on the bottom, and the one on the top is for the unknown. And you can see it sees this 187-108 ion that says it looks like it has this substructure involved in the spectrum. Let's go to the next one. So I'm on the third one on the arrows. Again, bromine and a fluorine on an aromatic ring. Again. So you can see a good many hits that show that the bromine and the fluorine are probably on the aromatic ring. So that helps me feel like that the proposed structure is reasonable, that it is an isomer of the structure that I drew originally. So in conclusion, the adaptive search greatly extends the effectiveness of all EI libraries in the characterization of unknowns compared to the standard similarity search. The standard search, when an unknown is present in the library, directly yields a proposed structure. In contrast, the adaptive search yields clues that allow the user to propose structure or structures. One must always consider sample history for identifying unknowns and take into consideration other techniques such as chemical ionization, accurate mass, infrared, NMR, and mechanistic data. And often more than one useful delta mass can be noted in search results. So you'll have to spend some time learning how to use the adaptive search in your work, but when you do, I think you'll find some amazing results. So also take a look at some of my other videos that I've made on the Wiley Mass Spec KnowItAll software that I think you might find helpful. So long.